Hello children, welcome back. Now let us move to the worksheet number 5 of laws of motion. So here we start with the first numerical. The action and reaction force referred to in Newton's third law is. So children, according to Newton's third law, for every action, equal and opposite reaction takes place. If action happens on one body, then reaction will take place in the other body. Okay, so action and reaction will be taken place only on the pair of bodies. If one body gives action, the other body will supplies reaction force. So action and reaction force are equal and opposite but acts on two different bodies, and this is given by Newton's third law. So now let us try to discuss in detail regarding the numericals. The action and reaction force referred to the Newton's third law is must act on the same bodies, may act on different bodies, or must act on different objects. Okay, and they must be equal in magnitude but opposite in direction. But here they said that need not be equal in magnitude. So this is a wrong statement. Must act on same objects. It's also a wrong option because they must act on two different objects. So now the question, confusion arises, whether it is may act on different bodies or must act on different bodies. The correct option is must act on different bodies. May means might be possible. There is possibility for the other case. No, it's compulsory that must acts on different objects. It's not may. So be clear, children. The only correct option among this is action and reaction must act on two different objects, opposite objects. So let us move to the next one, that is question number 2. The law which gives the properties of force is. So action, reaction, pay the body, forward, opposite direction, everything is something related to a property. So this property we are learning in Newton's third law. So the law which gives the property of the force is Newton's third law of motion. So which one, children? So Newton's third law of motion gives the properties of forces. So now let us try to what is Newton's second law of motion gives? It defines force. It gives the formula for force. It defines force. Okay, F equals to ma. What about Newton's first law? It tells us something regarding the inertia. Introduces force. Tells us inertia, about something regarding the inertia. So now moving to the third question, the earth attracts a stone towards itself. Earth attracts the stone towards itself with a force of 10 newtons. Okay, earth attracts the stone with 10 newtons. Then the force with which the stone attracts the earth is. For every action there must be an equal and opposite reaction. So here you take an earth and here you consider a stone. So if earth attracts the stone, this is taken as your action part, and the earth is attracted by the stone, this is taken as your reaction. Both are acting in the opposite direction with equal forces. Okay, F1 equals to F2. F1 and this is equals to F2. F1 is equals to F2 in opposite direction. Okay. So what is given is the earth attracts a stone towards itself with a force of 10 Newton. Then the force with which the stone attracts the earth must also be 10 newtons. Towards itself, direction itself is given as towards itself. So no need to mention whether it is minus or plus. Direction itself is indicated towards itself like this. Hence, the correct answer is, if it is 10, here also it must be 10. So the correct option is 10 newtons. So moving ahead with the fourth question, children, if action is of 10 newton, then the reaction will also be 10 newton. But in the opposite direction or same direction? Opposite direction. So answer must be 10 newton in the opposite direction. So option 3 must be true. 10 newton in the opposite direction. It's not 20, it's 10. Not in same direction, it is in opposite direction. So moving ahead with the next question, question number 5. Consider a porter, you know porter? Standing on a platform with suitcase which presses his head with a force of 200 newtons. So here is a porter who is holding a suitcase on his head. Okay, so you know railway coolie and all, they'll be carrying our luggages and all. Okay, so this porter is holding a suitcase on his head. So what happens? This suitcase presses his head with a force of 200 Newton. So this is an action part. Force acted by the suitcase on the head is action, that is 200 Newton. So take this force as action. The reaction force exerted by it is obviously the same 200 Newton in the upward direction. Okay. So this head, the force acted by the suitcase on the head in a downward direction is 200 newtons. So at the same time, the force exerted by the head on the suitcase is also 200 newtons in the upward direction. So the correct option is the reaction force is head exerts 200 Newton force on the suitcase. So the head on the suitcase is the correct option. Nothing related to earth. Okay, nothing related to earth. Suitcase on the head, head on the suitcase. Action and reaction, two bodies. Moving ahead with the sixth question. A man is at rest in the middle of a pond. A pond is there and the man is also there. So man is at rest in the middle of a pond on a perfectly smooth ice. So this person is standing on an ice block. You know ice block? So this person is standing on the ice block in the middle of a pond. He can get himself to the shore by making use of Newton's which law? So Newton's third law. For every action there is an equal and opposite reaction. If you want to move forward, he has to push the ice block backward. So after continuously pushing the ice block backward, he can move forward until he reaches the shore. So which law is used here? Newton's third law. Okay. So this person can get himself to the shore by making use of Newton's third law. The correct option is option 3. Clear, children? So let us also move with the next question, 7th one. In case of a book lying on a table. So what is this? Book is on the table. Action of the book on the table and reaction of the table on the book are equal and opposite and are inclined to vertical. So how are they? So this book and table, so something like this. So this book is lying on the table. Okay. Action part, table exerts some reaction on this book. This is a reaction. How are these two? This is the surface. Here is your surface. Action of the book on the table and reaction of the table on the book are equal and opposite and are inclined to the vertical. Are they inclined? Are they in the slanting position? No, they are not in the slanting position. Action and reaction are equal and opposite and are perpendicular to the surfaces of contact. This is the surface. Surface and action. How are they both? Surface and action. Perpendicular to each other. Surface and reaction perpendicular to each other. Of course, it is true. They both action and reaction are equal and opposite and also act perpendicular to the surfaces in contact. Both statements are true. But here it was given inclined, so that must be a wrong statement. Action and reaction are equal but act in the same direction. No, they must be acting in the opposite direction. This is also a wrong statement. Action and reaction are not equal. No, they must be equal. Action and reaction both must be equal. So, the only correct option among the statements is second one, that is action and reaction act equal and opposite and are perpendicular to the surfaces of contact. Second option is true. So let us move to the question number 8. Whenever an object A exerts a force on another object B will also exert a return force back on object A. The two forces are, how are they? A on B, B on A. Both are opposite to each other, equal and opposite to each other. A and B, this is your A and here is your B. Okay. If A exerts force like this, B exerts force in the opposite direction. So whenever an object A exerts a force on another object B will exert a return force back on object A. The two forces are equal in magnitude but opposite in direction. So second option is true. Equal in magnitude but opposite, not same. It's opposite in direction. So not equal is a wrong statement. Equal is a true statement, but not in same direction. They act in opposite direction. Hence, the only correct option is option 2. Let us move to the last question, children. That is 9th question. When we kick a stone, we get hurt. When we kick a stone, we get hurt. Due to which one of the following properties of the stone happens? What is that? Is it because of inertia, velocity, reaction or momentum? So we hit the stone as an action part and we get hurt because the stone exerts an equal amount of force in the opposite direction. That is, we exert force on stone, the stone also exerts force on us. Because of that, we get hurt. So that is a reaction force. Ours is an action force, stone's is a reaction force. So the correct option is reaction. The stone exerts reaction. Hence, we get hurt. So with this, we have concluded with the worksheet number 5 of laws of motion. So children, keep practicing. So take care. Until then, thank you.